Hello, everyone. I'm sure you all know my name at this point, but my name is Casey. I'm going to be talking to you about my project, which a lot of you have already heard a lot about, but more importantly, I'm going to talk to you about my mobility experience. So first, I'm going to give a little motivation into my project. As you saw in the title, I'm dealing with small modular reactors, but more importantly, my project can be applied to different nuclear reactors, such as candy reactors and various other like boiling water reactors. So zirconium is something that is used in nuclear reactors as one of the main structural components. It's used for fuel claddings. Um, I included this diagram here, so you'll see that the uranium oxide fuel pellets are enclosed by the zirconium and the zirconium oxide. But more importantly, zircaloy is used, which is a combination of zirconium and tin. So there's a problem that happens in nuclear reactors, and this is something called a loss of coolant accident. And a loss of coolant accident is basically something when the internal cooling system fails and it leaks water. And because of this water leaking and the cooling system failing, everything heats up, and it heats up to temperatures of 1200 degrees. And what happens is the water interacts with the zircaloy, and through an exothermic reaction, which I included there, the zirconium is oxidized and hydrogen gas is produced. So if you'll remember in 2011 Fukushima, this is how the explosion was caused. So my project comes in with developing a coating to protect zirconium, or the zircaloy, from reacting with this high temperature steam to produce the hydrogen gas and protect it in general. So zircaloy is used because it is corrosion resistant, it is neutron transparent, um, and it also has a high melting point. So with my project, I'm going to be doing my mobility experience in Regina. So the reason that I'm going to Regina is to work on this neutron reflectometry cell. And this is a high pressure and high temperature cell that allows you to do neutron reflectometry in situ. So the person who developed this, his name is Arthur Sidham, and he's from the University of Regina. He's an assistant professor there. So I would go and I would work with Arthur, and I would do these in situ neutron reflectometry experiments where we would basically simulate the conditions of a loss of coolant accident in a small modular reactor, for example, and then run in situ neutron reflectometry. And this would tell me information about the structural information about the zircaloy and what is happening to the coating as it's interacting with the steam. So the profiles we'd be interested in, more importantly, is the hydrogen and the oxygen profiles to see how the water is interacting with the coating. But overall, our goal is to develop this coating so that it protects the zircaloy, and neutron reflectometry is a really strong technique that will help me do that. So my mobility experience is in the works. We're still trying to decide if they're going to send me to Regina, but as of now, this is what's going to happen. But if anyone has any questions, that is everything.